Welcome back. In the previous video, we defined what a pointer is, and we also explained the concept of the stack memory as well as the heap memory as used in C++. We understood from there that the variables that we've been using so far are actually declared in a stack memory, and of course towards the end of this chapter we are going to look at how we can allocate or how we can work with a heap memory to store our information. Of course, we highlighted in the previous video also that for us to use the heap memory in C++, we must use the new keyword. So to this far, we've not been using the new keyword. We've been just declaring a variable and assigning some values to that variable. And of course, we've been using the name of a variable to access the value from that particular variable, or to even assign a value to that particular variable. So we've been doing so. You could access using a name from that variable location, but we've not been working with the address. In this unit, we said we are going to go through the concept of pointers, which will help us to work with the addresses. Of course, it's very dangerous to work with pointers. We need to have some discipline. But C++ and C give us that particular freedom that we can manipulate the addresses. In other languages like Java, Python, etc., they don't give you that access to manipulate the addresses. But C++ will give you that freedom. So it has got its own good part as well as the bad side of it. Okay, so after going through the differences between the stack and the heap memory, and we assuming that we have understood the differences between the two, we are progressing with our discussion pointers by looking at two operators that of course we're going to be encountering most often is as we go through this chapter. The first operator is called the reference operator, and another operator is called the dereference operator. So the reference operator is an ampersand. We've used this symbol or this operator before in our previous video when we were displaying the address of a num variable. Just to take you back, here we declared a variable called num and assigned the value 25 to it. And we are saying if we have an ampersand here and num, then this statement is going to display the address and not the value. So that is called the reference operator. So we read it not as ampersand, but we read it as the address of or the address to. So the ampersand symbol, as used in the example shown, is the address of operator or reference operator. So we say address of num as in our example. Another one is the reference operator, the reference operator, which is opposite of this. So the first one helps us to get the value, the address of a variable. While the second one, it uses the address to get the value, which is pointed by that address. So we use the asterisk, and it can be read as the value pointed by or the content of. So if we have a asterisk on a certain pointer or a variable, pointer variable, then that would be we are interested in the value that has been pointed by this. We are going to understand them better as we see some examples as we go. You should also remember that the asterisk symbol is also used to declare variables, pointers. So there should be a difference. You should know the difference between the dereference operator and that which is used in declaration, as we're going to see. The dereference operator is also called indirection operator. Maybe other books may refer to it as indirection operator, but the common name is dereference operator, which is opposite of reference operators. How do we declare pointers? The pointers are declared with the asterisk between the data type and the variable name. So this is just the difference that we have in C++. If you are to declare a pointer, you put this asterisk. There are two versions of it. All of them are acceptable. We can have asterisk as part of the data type, or you can have your asterisk as part of the variable name. Examples here, you can have it as part of variable name. For example, int pnum. So the variable pnum is a pointer because of this. This one, p price, is also a pointer. But as you can see, the star or asterisk is on the data type side, and this one is also a pointer. Which version is good? It all depends on you, but it's better to have the asterisk indicated on the side of a name in some other circumstances. But for example, if you are declaring a header file, or maybe function headers, or the prototype in particular, you may have a prototype which does not contain the name as we saw under functions. So you may need to have that one as part of the data type. But to avoid some confusion that may occur in some instances where you have two pointers on the same line of declaration, it's better to have the star as part of the name, because it shows that, okay, the first one is a pointer and the second one is a pointer. If you have something like maybe int, and you have maybe a and B, these are ordinary mini variables. But if you want to have both of them as pointers, and you just come here and do something like this, the implication here is only A will be considered to be a pointer, and B is not going to be considered as a pointer. So both of them are supposed to have an asterisk. So it's better to have this asterisk or this particular symbol close to the name in that instance, and here you also have that. So you are declaring both A and B as pointers. So here we are showing you a complete picture of it. We have declared a normal variable, which of course you can assign any value if you want, and we have declared a pointer, and this pointer, as we indicated before, will only allow the address. It cannot store actual value. So we are taking the address of num using the address of or the reference operator, the address of num, and that address is going to be assigned to our pointer. So our pointer now has got the address. If we can have the cout, then this is going to give us the address instead of the actual number. There's actually no number here. And if we can also have another statement, that is the cout, as we saw before, the address of, and we have num, then the address that is displayed here and the address that is displayed here will be the same, because the pnum is just keeping the address of that, and here we are using the reference operator to get the address of num. So here we are now showing you how you can display the value that has been pointed by the pointer. Here we have the pointer, which is keeping the address of num. Assuming that the num here had a value, probably maybe 25, and the pnum here is just storing the address of num. What we have at the end is two ways that we can access this 25. We can access this 25 by using num, maybe cout num, or we can use the pointer to get 25 still by using a dereference operator. So here we are showing you how we can get 25. And that 25 is going to be printed out by putting a star, which is a dereference operator. So here we are saying we are not interested in the address, but we are interested in the value for the address which is stored in this. So we are going to get the value. Pnum is pointing to a certain variable, and we want the value for that variable and not the address of that variable. So this is going to give us 25, assuming here we had 25 for our initial value. But if you don't put anything here as this dereference operator, what you're going to have is the address of that variable. We should remember that there is also an address of the pointer, but here we are referring to the address of that variable, which is num in our case. Okay, before we go to the next section, just to make a clarification of what is happening here, let's assume we have our memory. This is our memory, and we have made our declaration for the first one, which is num, and that declaration has been given this. Of course, it has got a variable of the memory allocation address, which I'm going to assume that is 1001 as address, and we have named it num with a value 25 from what we have here, and we have declared another variable. Of course, it's a pointer called pnum. So here that variable pnum can be assigned any address. Let's assume it's been assigned this address space here, and its name is pnum, and this pnum, the value of this pnum, okay, before that, the address of this pnum, let's assume is 004, and the value of this pnum is what? It cannot keep the actual value. Remember, the value of that pnum is the address of num. So the address of num is 1001. So the value for the pnum is 1001. The value for num is 25. So what is happening now is, if we just come in a statement and say display pnum, as we've done here without the asterisk, if we just say cout pnum, what is going to be displayed is the content. Because if we have a statement that says cout num, that statement displays 25, the content of num. And if we say cout pnum, it's going to display the content, and the content is 1001 in our case. But what is 1001? 1001 is the address of num. Yeah? So we have this one is what is kept here. So display pnum is going to display 1001. Display num is going to display 25. But if we have something like display the value referenced or pointed by this address, then we're going to have 25. That's what this statement is trying to do. We say display the value pointed by this. So the value pointed by 1001 or the value on the address on 1001 will be 21, and we use asterisk to do that. So if we have asterisk, then it is going to go to where that address is, and it's going to get the value for that address and give us that value. So that is a clarification that we can give for you to understand the concepts of a pointer and the normal variables. They are all variables, only that the pointer is keeping the address, probably address of another variable. As we're going to see later, the pointer can also store the address of a pointer, because as we have seen here, the pnum has got an address. So if there's another pointer and that pointer is pointing to this, it's going to keep this value as its as the address for that. This pointer is keeping this value. That other pointer which is pointing to this can keep this value. We're going to see that when we'll be looking at a point of a pointer. There are some arithmetic operations that are actually associated with the pointers. Not, of course, multiplications and not divisions, but we have what we call the decrement and increment, adding and subtracting. So we have 4 operators that we can use. We can use the plus something to add, or plus or minus minus. What we are actually subtracting or adding are addresses. Okay, not necessarily that we have 2 addresses and we are adding them together, because if we have plot A and plot B, plot A as address A, as plot B as address B, maybe somebody lives at plot A and another one lives at plot B, we cannot add them together. We cannot have plot A and plot B added and it gives us a different address. No. So if you have 2 addresses, you cannot add them together. But we have special arithmetic operations that we do with pointers or with addresses. If we have, okay, let's take the same example of plots. Assuming that this is an area and we have the first plot here, and the next plot is here, and another plot is here. Assuming this is plot A, and this is plot B, and finally this one is plot C. We cannot say take the address of plot A and address of plot B, no, and add them together, no, or subtract them, no. But what we can do are some sort of operations, like if you're on plot A is next to plot B. So if you just move 1 step, if you just have +1, then you are going to have, or you are going to reach plot B. And if you are on plot B and you have +1, you are going to reach plot C. So the +1 is just going to help you move from one address to the next, to the neighboring address. That's what it's going to do. So if therefore the plots and you have +1, it means you are moving from plot A, from plot number 1 to plot number 2. If you are on plot number 1 and you have added 3, it means you are going to jump plot number 2 and plot number 3. And you are going to go on plot number 4. Because if you had plot number 1 and you were +1, you were on plot number 1, this would have taken you to plot number 2. And if you're on plot number 1 and you have +2, then this would have taken you to plot number 3. And if you have +3, it means 3 steps from 1, and that will take you to plot number 4. So the kind of arithmetic operation that we do here, or the kinds of calculations or the arithmetic operations that are involved with pointers, are actually such kinds of, we are not adding the addresses together, but we are just showing you how you can move from one address to the other. So we use only the increment. You can only increment by a certain value, or you can decrement. If you have a plus, it means just move to the next address. If you have minus, it means move 1 step to the previous address. If you have +1, then it's the same as plus plus, just to move to the next address. But if you have plus 2, then move 2 steps forward. So it's going to jump the next address and go to the third address. Okay, so anyway, this statement says it all. It won't be possible and it's sensible adding addresses together, but we can do the increment and the decrement. Okay, so the plus plus or the minus minus or plus whatsoever, what we are calling a point arithmetic, can be utilized or understood better when we apply them to arrays. We should remember that with arrays, the values are actually stored in memory in a contiguous manner. In other words, if you have an array of 5 numbers, then the values for the 5 numbers are just next to each other. So the first element will be on probably, for example, address A, then second element will be on address B, which is the neighbor of address A. They are next to each other. So we can use plus plus to move from one address to the next. If we want to access the address of next element, we can use plus plus. So here we are trying to show you that, I don't know if you have experimented this one before, but if you have declared an array and you just have a statement, maybe an array of numbers or maybe an array of grades, maybe you declared something like ages, or anyway, let's just have ages. If you have something like ages, which is an array maybe of 5 numbers, and you just maybe you give the values to all those 5 spaces, and you have something like cout ages without specifying an index. The cout ages will give you the address, and the address which is given is the address of the first element. This is very important. If you want to display or just want to use the name of an array without specifying the index, the name of that array gives you the address of the first element. So array names can be used as pointer constant, and pointers can be used as array names. So with that, we are able to go in both directions. You can use array names as pointers. You can use also pointers as array names. As we're going to go, as we're going to see and demonstrate later. But the point here that we should take home is, if you want, you just use the array name without an index. That array name gives you the address of the first element of that array. So if the array has got 10 numbers, the name of the array will give you the address of the first element. And you should remember that the elements are stored in a contiguous manner. So using the array name, we can access the rest of elements, because the first the name of the array is taking us to the first element. And using point arithmetic, we can move from first address to the second address using +1, for example. So we can access the address of the second element by just adding 1. It will take us to that, and we'll be able to get the address for that element. So the identifier of an array is equivalent to the address of its first element. Very important. So we are saying if we know the address of the first element, then we can know the address of the second element, because we are just going to advance one step. And we can go to the next element by advancing another step. This is a key. So in other words, we are trying to say that we can access the elements of an array using pointers. Here's an example. If we have an array and we have the statement that just displays or say out the name of the array without necessarily including the index, that will display the address of your array element number 1. And if you put +1, it's going to address the address of array element number 2. If you put +2, it is going to give you the address of the array element number 3. So it goes like that. So to access the value of an array at index number 1, if you are to use it as a pointer, you can actually use this syntax. So array name +1 is going to give you the address of element on position or index number 1, which is the second element, and we can have a dereference operator here. So it's going to give you the name of that particular array. What we are saying is, if you have array maybe called A, and this array has got let's take that maybe this array has got 5 maybe 3 elements. We have 2, we have 10, and we have maybe 3. Oh, okay, sorry, we wanted this one. So this is our array, and if we are to come up with a statement that says cout A, this statement cout A is going to give us the address of 2. It's not going to give us the 2, but only the address of 2. And if you want to display 2 using this syntax or pointer notation, then we can have cout, then this, then we can have the dereference operator A. This one is going to give you 2, which is the value pointed by the address of first element. So it is going to give you 2. And if you want to get the second one, which is 10, then you need to have the dereference of A plus 1. Something like that, because A plus 1 is going to give you the address of the second element, and the dereference operator here is now going to give you the actual name of that element for that array. Remember, the arrays are constant actually pointers, because you cannot use the array name to assign any value to that, but you can just access values or modify the values for the elements in it, but you cannot assign any other address to the array name. So arrays are said to be constant pointers, hence you cannot assign it to anything like this. So if this is an array name, you cannot give it any other value, you cannot give it any other address, you cannot have an address of something, maybe ampersand something. No, you cannot. But it's possible to take the address, or to take, the name of the array and assign it to any other pointer. So you can take the name of an array and assign it to any other pointer. It means now the elements for this array can also be accessed using this pointer. Try to come up with a program. Check yourself, guys. Try to come up with a program that should store 6 integer numbers in an array and display them all using array notation. And you should also try to display them all using a pointer notation. The array notation is actually what we've been doing under the unit of arrays, where we are using the indices to do that in the square brackets. But now in this unit, we have also introduced to you another way of doing that you can access the elements by using the array name plus the index position. So array name plus 1, this will take the value on index number 1 if we have the arithmetic notation, or we have the dereference operator here. So I want you to use this for the second part to display all the numbers using pointers. Okay, thank you guys.